you joined us. We are going to be having an overview session for the SunSynk inverters, that is both the 5 kilowatt and the 8 kilowatt in as the training progresses, you can just drop that question on chat and then I'll respond to it. And then if I cannot, then Brian is going to respond to them to those questions at the end of the session. So Brian, it's over to you.
Good day, everyone. I'll quickly share my screen. Okay, can everyone see my screen? So, okay. Can everyone see my screen? Okay. Today we'll be looking at SunSynk, which is one of our residential product range. So SunSynk, it's a purely hybrid inverter. When we say purely hybrid inverter, we mean it can supply both your critical and non-critical loads with PV and battery. That is to help you fully utilize your PV array. So basically, the inverter can work as a grid tie. At the same time, it is an off grid, so that makes it being a purely hybrid inverter. So SunSynk inverters, they help you to manage your high power loads as well. For instance, for a household, if you have high power loads like pumps, stove, geysers, and all that, you are actually able to use your PV to supply those loads, but it can only do so when there is grid. The moment you lose grid, the inverter can only supply loads that are connected to the backup port. Another cool thing about something is that it comes in with a built-in generator integration port, so you can actually wire the generator to the inverter. Then it has an automatic transfer switch, which is the ATS function, to say when the batteries are running low, in a case where you're running as off-grid, or during load shedding, then it can automatically start your generator if the generator supports that function. So like any other inverter, this is a residential product range, a pure sine wave inverter. So it can supply all your loads, that is standard 230 to 250 volts, 50 hertz. So this is the system overview. This is how the SunSynk inverter looks like. It has basically everything you need or incorporated on the unit. On our right side, we have description for the inverter. So the inverter is a local screen for local monitoring, and then it has buttons for scrolling around, and LED indications to notify of the status in operation, and if there is fault, then it will it will also show a red light to notify you that there is a fault. The inverter supports CAN bus and RS485 for battery integration. We mainly distribute the SunSynk inverter with a Freedom 1 battery, which supports CAN bus. So all you need is to match the CAN bus pins to the battery type that you'll be using. That is, if it's lithium. If it's gel batteries, the inverter also support a wide range of batteries, from lead acid, gel batteries, and mostly now in the market, people are now using lithium. So when you open the front cover for terminations, you get access to the DC bus. So the inverter doesn't offer a plug-in termination. You have to terminate your cable with the screws provided. You just need to run a specific size of cable depending on your battery bank. For an 8.8 kilowatt inverter, the minimum cable size it's a 50 millimeter cable for DC, and then on item 10, if it's quite visible, that's where you have your RS485 port. If your battery comms cable you are using RS485, that's where you get your RS485 termination. Mostly if you are using lithium, most lithium batteries, they use a CAN bus, so you terminate on item 11 on the diagram, and then it offers 3 termination ports. All these ports can work as output. 2 of them can work as input. So we have got grid. So the grid port, it's an grid input to the inverter, and at the same time, the inverter uses this port as an output port to backfeed power to the non-essential sites. We'll look into that into that schematic on the following slides. And then we have the load port. This port is always an output port. So basically that's the backup port. On this port, you should connect all your backup loads. Your backup loads should be restricted to the size of the inverter. SunSynk inverters, they come mainly, we distribute the 5.5 and the 8.8. They have, however, a peak power of 2 times the full load to cater for starting currents in case in instances of inductive loads, but that it can only do that for 10 seconds. So if you have your pumps and all that, it can actually hold power up to 2 times. Sorry, can we? Yeah, and then we have got the Aux port, which is a generator input port if you are using the generator. However, you can also use this port as an output port. We'll look into it, how to configure it to work as an output port. Can we please mute? And then the system also comes with built-in PV terminations. For the 5.5 kilowatt, underneath there's an MC4 connector, so you need to wire your PV strings there. For the 8.8, it comes with push-in plugs, which is item 5 on the 8.8 kilowatt inverter. So you just need to run your strings, and then you just need to terminate on the inverter. So the inverter also, as I've said earlier, the inverter is a pure hybrid inverter. So it will need to keep track of your grid and the load consumption, so that it will be able to backfeed to the loads at the same time, monitor for export. So the inverter comes with a built-in CT meter. So all you need is to wire the CT straight to the inverter. The points are provided on the inverter as well. So your CT, it comes with the inverter comes with a CT with a cable length of 10 meters. However, you can extend it to another 10 meters. But when extending the cable, please take note to use the same cable type. If you use the general purpose wire cable to extend your CT meter, the inverter won't be able to read the CT meter. So the one of the advantages.
Sorry, Brian.
Yes.
Sorry, it's Marius here. I just want to find out something quickly, what we've picked up. I don't know if there's someone else that can also say that they've picked it up in the industry, but the 5 kilowatt inverter on the output side, we've picked up that the live and neutrals are swapped around. Because when we measure between neutral and earth, we get 220, but between live and earth, we only got 0 volts there. So is there anyone else that picked it up in the industry?
Okay, on that, SunSynk inverters, that's the standard SunSynk wiring. Those termination points at the top, they are for the PCP port. As an installer, you should just take note of the labeling and then follow the labeling. However, if you wire it around, it still works. But whenever you're wiring, follow the labeling on the PCP port. The top wiring is for the circuitry of the internal circuitry, because before it comes to the load, it also supplies the circuitry port inside. So what you should do is to just make sure you follow the labeling on the PCP port for your live and neutrals. So the top part, yeah, I've got many inquiries about that. All you need to do is just follow the labeling on the PCP port for your wiring. The top part is an internal setup, so the cables are terminated for the PC port circuit.
You see, the problem that bothers me, Brian, if you say we need to follow that, if the live and neutral is swapped around on the output side, then then my live actually becomes a neutral, which means my neutrals are being fed through the circuit breakers, and my neutral terminal is actually becoming live, which to me is not good practice, obviously.
Okay, the top part, when the inverter works, or it's when it's shut down, the moment you would valve, when it's working on off-grid mode, then your neutral will be live. So on wiring, that's how it's prescribed from SunSynk. And we have actually made a query with them, and then they said the inverter, that's how it works. So you should, when wiring, follow the labeling on the PCP port, because the upper part is for internal circuit. That's why it's connected in that format. But this, however, is for this page. The next page that will be coming, they would correct that.
So what we have done is we have raised that issue because we've had quite a couple of people complaining that there's inconsistency. Because if you look at the top part and the bottom part, they seem like the wires are swapped around. So we've raised that issue with SunSynk, and they've said that for the next batch, they are going to standardize it so that on both sides it remains the same. So for now, like what Brian is saying, just look at the labeling on the PCB. You won't go wrong. You can go ahead, Brian.
Okay. Yes. So the inverter is it supports Wi-Fi and GSM for monitoring. However, currently in our region, we only support Wi-Fi for connecting to the server. So if you intend to monitor the system online, you need to have a Wi-Fi dongle. The inverter, all the programming can be done on the inverter, on the physical unit. They're still working so that you'll be able to do some of the major settings remotely. but currently all the settings that they can be performed on the screen. And actually on the screen you can actually view everything that you need, from flow charts to settings. You can actually all your configurations you can do it on the screen. And then the system comes with built-in 3-stage MPPT, main for battery optimized performance. So for the 5 kilowatt system, the MPPT rating is a 125 to 450 volts, 11 amps. So it means when you're using a 5 kilowatt, all your strings has to be in, all your panels in a string have to be connected in series. And then for the 8 kilowatt inverter, it comes with a 125 to 450 VOC and a 22 amp current rating. So you can connect, if your PV array is quite big in and the string length, there will be more than 450 volts, then you can actually connect 2 panels in parallel in a string. However, this means you would need a 2-to-1 combiner box before wiring to the inverter. As I've said earlier, the system comes with an auxiliary load function, which you can actually use it as a second load output for your inverter. So you can actually use that to push power to high power loads which are not directly connected to the inverter. That is when your batteries are fully charged, and the inverter can hold peak powers for up to 2 times its rating for 10 seconds. So the inverter is quite compatible with wide range of grid voltages, and you can actually adjust your under and over voltages, and it's compatible also with wide range of generators, as long as the generators are stable and produce power within our NRS range of voltage and frequency, then it will be compatible to the system. And the inverter, as I've said, it's a pure hybrid, so it offers you to fully utilize your PV array to the loads for optimum self-consumption, and it has an auto recovery for AC, and so the inverter offers UPS, uninterrupted power supply. So whenever it loses grid, when it was using the grid to supply your loads, then it automatically change over to backup mode, which is off-grid mode, and start using your battery to supply your loads. And if you are watching your TV, it won't switch off, giving that uninterrupted power supply to your loads. And so when the inverter is operating as in island mode, that is in off-grid mode, when you don't have grid connected to it, you would need to have your neutral and earth bonded together, right? So you would need to, if let's say the premise is the earth and the neutral, they're not bonded together, the inverter offers a feature of an auto earth bonding feature, which is a relay. It has an output of 220 volts, so you'd need to wire through a relay such that when the system loses grid, this relay, this output is energized, and then it will energize your relay to bond together your earth and neutral. And as I've said, the inverter offers a screen with good aesthetics, and you can actually do all the programmings. You can actually set the inverter to work in your preferential way, in terms of which power do you want to utilize first, how to maintain your battery such that you can keep reserve for load shedding and all that. It offers that fully programmability function to select all those functions. And the inverter comes with built-in features for protection from overload, over temperature, short circuit, all those features they're built in. So if an overload happens in your wiring, the system will quickly detect that. It has a built-in earth leakage of 100 milliamps. It comes also with built-in PV arc protection, so it can actually detect any arcs on your PV's array, that is whether it's positive to negative, positive to ground, negative to ground. It can quickly detect that and give an alarm. It comes also with a PV lightning protection, that is basically as a built-in surge protection type 2. When there is a lightning and then there is a surge in the PV array power, and then it will detect that and then protect the inverter, and it will also give an alarm to notify you of the force that it had incurred. Please note, the system comes with string input reverse polarity protection. So if you reverse your strings, basically to give an alarm to notify you that your string polarity is reversed. However, this is different to battery reverse voltage. So whenever you're installing a SunSynk, before powering on your battery, please make sure you have wired it correctly. Like positive is terminated on positive. If you reverse polarity on the battery side, you can actually damage the inverter, and that is not covered under warranty. So please take note of that. However, for the PV array, the system comes with reverse polarity protection, but for the battery, it doesn't have that. So, and then for the lithium batteries, you can just, if you connect your cable, the system will automatically pick up the battery and pick up the battery, all the battery protection readings from the BMS, that is the charging current, floating voltages and all that. And then and then that it will use those for optimized battery protection. However, if you are using an LG or a lead acid battery, then all those functions you would need to set them manually on the battery setup. We'll look more in detail on that on our tomorrow session on commissioning. So this is basically the architecture, the system diagram of the SunSynk inverter. So the inverter offers two MPPTs, right? So this architecture is for an 8 kilowatt inverter. You'd see on your PV strings, you can actually parallel two strings to one MPPT. So this setup is for the 8.8 kilowatt inverter. So it has a DC switch, which basically isolates your PV to the internal system. However, when you're installing PV, it's recommended to install a protection box, which is basically fuses and surge protectors. Although the system has a built-in DC SPD surge protector, which is also a type 2, but however, it's recommended that you would also install an external protection box, and then basically it goes to the filtering circuits up until the AC to DC conversion. And then on the output side, on the AC side, also the system is also equipped with a built-in AC SPD for your protection. So this is how the internal structure of the inverter looks like. The flow chart of power inside the inverter. So the wiring diagram for the system, you would have your PV array wired to the inverter, to the PV input points, and then you would have your grid in Karma. So as I've said, the system is a pure hybrid. You need to utilize all the PV to your loads, both critical and uncritical. So your CT meter has to be installed right after the mains breaker. before supplying anything to the house, that's where you should clamp your CT, so that it will be able to monitor both your critical and non-critical loads. So soon after your main incomer from the grid, it passes through the municipality meter and then to the mains breaker. Soon out of the mains breaker, then that's where you need to hook up your CT, wire it to the inverter. So I usually recommend when you are siting a place where to install the inverter, try and find a place which is much closer to the main TV, such that you can cut the distance short between your CT and your inverter. And then from your CT meter, the same line, you can you then supply your non-critical loads. That is high power loads, stoves, geysers, and so forth, and high inductive loads. Preferably, you connect them as non-essential loads, right? And then the same line then goes to the grid point on the inverter. So the system uses this point as an input-output port. So when the system runs short of battery and PV to supply the non-essential loads, it will simply use this port as input and then supply your essential loads on the connected on the load output. However, if there is excess or surplus from PV or battery after supplying essential loads, then the system would simply use this port as an output to push back power through backfeed to your non-essential loads. That is your high power loads. And then the meter is there to monitor in cases of zero export that power is not fed back to the grid. It's only supplied for self-consumption. So basically the CT gives the reference for the inverter to produce the set point for the inverter. And then the second port is the essential loads, which is the load output. So on this port, as I've said, you need to keep your peak loads within the rating of the inverter. The inverter can, however, hold surge current for 10 seconds up to 2 times the rating, but you need to keep it within the rating of the inverter so as to avoid the inverter overloading. And then the third port is the Aux port, which you can actually use as a generator input port. We'll look into that in detail in our following slides. Or actually, you can use it as an output port if you have surplus PV after supplying your essential loads, usually in an off-grid scenario, and then you can use this port to supply your high power loads. That is if you have excess PV. So this is how the screen looks like. It has a system flow chart where you can actually see the flow of power, how much power coming from PV, how much going to the battery, and how is it distributed to the loads. If you are fitting back to the grid, the CT meter will actually read a negative power to show that power is going is flowing into the grid. And then this is the SOT for the system. So from your PV arrays, this is to refer to an 8 kilowatt system. So from your PV strings, you can connect your strings to the protection combiner box if you have an 8 kilowatt. And then the output of it, then you wire it to the PV termination point on the inverter. So when you're installing battery, it's recommended, I'm sure under electrical regulations, if you're an installer, you know that you always need a battery disconnector. It's recommended to install a protection box for basically a battery disconnector, basically to be a fuse, or you can use even an isolator on the positive terminal such that you'll be able to cut out power coming from the battery to the inverter. And the fuse rating should be rated to the size of the inverter. If you are using an 8 kilowatt, the DC fuse rating is 190 amps. So something around 200 amps fuse would do, or lesser than 190 would do, so as to protect both your inverter and your batteries as well. And then your CT, you just need to wire. It comes with a cap with 10-meter length. As I said, make sure when you're extending, you use the same cap material with the one that comes with the CT. Usually, if you use different cable types, then the inverter won't be able to detect the CT. And then from your grid incomer, you supply your DP port, your main loads, your non-critical loads, and then the same line goes to the inverter, preferably through an AC protection box as well. And then the output of the inverter, which is the essential loads connected on the load port on the inverter, will then be wired to the non-essentials through an AC protection box as well. So installing a SunSynk inverter, the inverters, they are IP65, the protection degree. So the inverter can be installed outdoors as well. The operating temperature, it's around minus 25 to 60 degree, which is basically within our temperature for our region. And then the inverter, when the temperature gets more than 45 degrees, the inverter will start derating. So if you are to install the inverter in a confined area, let's say in a closed room and all that, it's advisable to install also an air circulation mechanism or an air con, such that it can cool the environment. Because the moment the temperature goes above 45 degrees, then the inverter will start derating. So the inverter, when installing it, make sure it's installed on a firm platform or on the wall. The distance between in front of the inverter should be at least a meter clear, and then a meter from the ground, and then about 60 centimeters from the top of the inverter to your roof, and then at least 30 centimeters on the sideways to allow free flow of air when the inverter is cooling. Ensure that the inverters, they are firmly secured, and the inverter has to be installed vertically. Make sure you don't install the inverter slanting at an angle. Just make sure your inverter is vertically mounted. When using multiple inverters, make sure you keep a space of a meter between the inverters for such that there is a free air circulation for cooling. And then the battery connection to the inverter. SunSynk inverters can be connected with a wide range of batteries, the mainly being the AGM and lithium in the market. And then the minimum cable size should be around at least 50 millimeter diameter, wired through a fuse protection box. Because if you use a smaller cable size and your inverter is operating at maximum, most of the times you find your cable overheating, and and that contributes to losses and system inefficiency as well. So as I've said, the system does not come with a battery reverse voltage protection, reverse polarity. So whenever you're installing, please take note. It has happened with quite a number of installers that you swap around the polarities, and when the inverter gets pegged, or because of that, it will invalidate the warrant of the inverter. So whenever installing the inverter, please take note of the polarity, and take note of the polarity of your batteries. When you are using the lithium battery, depending on the type of communication that the battery support, white clipping, CAN bus, you need to hook up a cable from the battery to the inverter on the CAN bus port. Now, you should take note of the pin layout of your battery and the inverter. The SunSynk inverter uses pin 4 and 5 as high and low respectively. So if you are using any lithium battery, you should take note of the CAN bus ports. For our Freedom 1, it uses 7 and 8 as high and low. So when you're using a SunSynk with a Freedom 1, then
as you can.
So when you're using a Freedom 1 and the SunSynk, there is need to crimp a separate cable. On the battery side, you need to match 7 and 8 to 4 and 5 on the inverter side. If you use a straight cable, which in most instances, that's what people do, the inverter won't be able to communicate with the battery. So after I've connected your comms cable from the battery to the inverter, you need to go to settings and then LIPMS, and make sure that you could actually read the battery voltages, that is the mean charging voltage, current, and all that. If you still get zeros on the LMIPMS, please check your cable. Depending on the battery type, you would need timely, you would need to install a what you call an end of termination resistor, an RJ45 end of terminator, or to notify the inverter to say this is the last battery on the chain. So whenever I use a lithium, after connecting, you need to check your LMIPMS to see that to check if the battery voltage is. You can actually read the battery voltage from the comms line. And the other thing that installers would encounter, you would actually read the battery voltage from the LMIPMS, but at the same time the inverter is giving a fault of low battery. So the low battery fault comes, the inverter will be detecting a low battery at its termination point. So timely you find the battery it has a fault, so it's not giving any output. But however, the BMS would actually transfer data to the inverter to say the battery voltage is at this level and all that, but the physical output of the battery is not giving out that power. So you would need to measure your voltage at the termination and make sure that the voltage at the termination also tallies with LMI PMS when the inverter gives a low battery voltage fault. And then installing the AC grid. AC mains should always be connected on grid point. So when you're installing your grid input, it should always be installed on grid point. If however you install it on Aux port or load port, it can, if it damages your inverter, it will not be covered under warranty. So you should always make sure that your grid incomer is installed on grid point on the inverter. If you are using the inverter without batteries, as I said, the SunSynk inverter is a pure hybrid. You can actually use the inverter as a grid tie. So you can actually use the inverter without batteries. So when you are using it as a grid tie, the only port that will need to be connected is the grid point. And when you are operating it as a grid tie, as a grid tie inverter, you cannot use the aux port. So when you are using the inverter as a grid tie, you cannot connect any loads on the load port. You cannot connect the generator or any loads on aux port. The only port that will be used by the inverter will be the grid tie, will be the grid point on the inverter. However, if you are connecting, if you are using the inverter as an off-grid, that is in remote areas where there is no grid at all loads should be connected on the load port, right? Because when the inverter is operating in island mode, it can only supply loads connected on the load port. That is, when you lose grid or in off-grid scenarios, the only port that will have output will be the load port. So both essential and non-essential loads will need to be connected through this port. And when you're connecting in this scenario, you can now connect your generator on the grid point, right? And the generator will basically act as a grid to the inverter. So when you're on off-grid mode, you can use the grid point to connect your generator, right? But all loads, yes.
Sorry, man, just Morris again. Just on that point there, we've got an application where we might obviously have a complete off-grid scenario like you're explaining now. And we definitely want to have to make use of a generator if obviously we had a couple of cloudy days and the battery can't hold the loads and stuff anymore. Does the inverter give you the functionality to start the generator at a certain point, or how will that controls work? So because obviously you don't want the generator running all the time with the auto changeover, you just want it to kick in when the battery, for instance, get to 20% or 10%. Is there a functionality that the inverter can do that for you or not?
You can actually set the times. We'll look into it when you're on the commissioning slide tomorrow. You can actually set the times. Let's say when you want to control the aux port to give an output for ATS. So, but now you cannot. You can also set it to give an output. Let's say when the battery goes to 20%, and then you can actually give an output to start up your generator, and then you use the generator to charge up the batteries and all that. So we'll cover how you set it up on our tomorrow session, but it's possible to use your generator when the battery goes low, and then the ATS will give an output to the generator. If the generator supports ATS, they need to automatically start, run to the system as a grid, connected on grid point, charge the batteries and all that. And then when the battery can actually switch off the port, let's say when the batteries get to 100%, then it will automatically switch off the genset and then start running from the batteries.
Okay, and just on the second point that you're going to get to now, which is obviously when you're using the inverters in parallel mode,
yes,
you cannot use the gen or the aux port. So if I need to parallel to obviously increase the capacity in an off-grid scenario where 8 kilowatt is not going to be enough, so I need to double up to 16 kilowatt, will I not be able then to use the generator?
Yeah, in that, if you're in off-grid scenario, then you can use the generator, but you cannot use the gen port. So when you are wiring the generator in off-grid situation, you would wire the generator as grid input, not on aux port. Whether you have a single inverter or parallel inverters, the generator will be wired on the grid input. So basically, if you're in parallel mode in off-grid scenario, then you wire your generator, you will be wired on grid, so you are not using the aux port. But in a scenario where you have a grid connected on grid point, and then you want parallel inverters, then you cannot use the aux port, because the grid port is already occupied. Alternatively, we'll also touch base on it on our next slides. You can use a changeover switch between your grid and the generator, and then wire the input on grid. So the system basically will record the power as grid, regardless whether it's grid running or generator, because the input is wired on the grid side of the inverter.
Right, thanks. That would have been my next question, if we use an auto changeover. Okay, but thanks, appreciate it.
Okay, we'll touch base on that as well on the next slide. And then, as I've said, the coil, you need to install the sensor, the CT, which is the sensor at the grid incomer, because this sensor is there to give a set point for the inverter to produce in scenarios for self-consumption. But however, if you intend to feed back to the grid, then it's not mandatory to install the CT at the incomer. You can just clip it on any of the lines, such that it can give you a reading. Because when the inverter cannot detect the CT, then it will basically produce to maximum, and it won't be able to give power to non-essential. So you would need the CT connected. Right. So if you are for self-consumption, it's mandatory to install the CT at the grid incomer, such that the CT will be able to measure everything, all loads in the premises, and then give a set point for the inverter to produce, such that if there is surplus after supplying essential loads, then it can simply push back that power to the non-essential loads. And the cable can be extended by 10 meters, but you should make sure you use the same cable properties. Unfortunately, I'm not sure the exact cable size type for the CT. I'm sure I'll check, and then I'll let you know on our tomorrow's session what cable type you should use. But if you use a cable, it's a fine strand cable. So if you have usually those cables, which I'm not sure what's the name, the one they use for speakers, with that one you can actually extend your cable. But with a general purpose wire, obviously that's the cable which should be available when you're doing installations. If you extend the CT meter with that cable, you won't be able to read the CT on the inverter. And then the inverter is installed with MPPTs for maximum power point tracking. The VOC, the open circuit voltage, the maximum open circuit voltage for the system is 450 volts, right? So it means with modules, even the 550 watts that are now coming into the market, you can connect them in series. However, this brings a challenge when we look at the open circuit current. 550 volts, the high power modules. So the current open circuit current of the system ranges around 12, 13, thereabout, and the MPPT rating for a 5 kilowatt, it's 11 amp. So it means it will give a challenge if you have good radiance and you are using 550 watt modules, then the system will get an overcurrent alarm. So the 5 kilowatts system, you should preferably use with modules lesser than 500 watt, because the current rating is within the spec of the inverter. The PV industry is ramping up. They are bringing high power modules and all that. It's cool to have 550 watt panels, but you should take note of the rating of the inverters as well, because that has been a challenge of late. Guys who get 550 watt panels, connects them to a 11 amp MPPT inverter, and then the inverter will constantly be giving overcurrent alarms. So please take note of that. However, if you are using an 8 kilowatt inverter, even if you use the 550 watt modules, they won't give a problem. because the MPPT rating it's a 22M, but it means all your strings has to be in series, right? Because the moment you parallel the strings, it means if the panel produces 12 amps, if it's a 550, then you would have around 24 amps, which is above the MPPT rating as well. So please, whenever you are designing your system, please take note of the VOC and IOC for the inverter and the module that you'll be using. So the maximum MPPT VOC is 450 volts, and the minimum is 125 volts, but the startup is 150 volts. So you should have a minimum of 150 volts for the MPPT to start working, a maximum of 450. However, when the MPPT is in operation, then if PV drops below 125, then it will switch off. So when designing your PV array range should range from 150 to 450. So if we use 50 for calculations, that's about a minimum of 4 panels and a maximum of 9 panels for in a string if you are designing your string. And when you are for an 8 kilowatt system, which you can parallel 2 strings on an MPPT, make sure that the MPPT string, the string lengths connected to this MPPT, they are of same type and length to avoid leakage current to the inverter. So your strings, if you are to parallel your strings on an 8 kilowatt, you can have, make sure the number of panels is the same, and you can actually have one MPPT with parallel strings, while the other MPPT has got only one string. It's not mandatory to say when you parallel strings, both MPPTs has to be paralleled. It has to be parallel. You can actually parallel one MPPT and the other one you just have one string with panels in series. And then our next slide will look into integrating a generator to our systems. Yeah. In many instances, installers would want to integrate a generator to a solar system. The rule of thumb when you are integrating a generator, the generator should be able to supply a peak power or surge power, right? So if you have a load of 10 kilowatt, your generator should be able to supply 10 kilowatt. If it happens in a scenario where the inverter cannot power up those loads, all the loads, then the generator should be able to ramp up and supply power to the loads. So the generator, you can connect it on Gen Aux input or as a main input that is on grid point. If you are using multi-inverters, like you have said earlier, you cannot use the Gen Aux port. This is simply because it will cause imbalance within the inverters, and this could actually reverse power on inverters, which can cause imbalance of the system. So if you are paralleling inverter, whether in a single phase, 3-phase scenario, you cannot use the Gen Aux port. If you intend to use the Gen X, the generator, then you would need to actually install a changeover switch that will simply change between your grid and your generator, and then wire this output of the changeover switch to the grid point on the inverter. The system, as you have said, the system provides can output actually an ATS signal, which can be used to start up the generator when the batteries are running low, or in a scenario where you are on off grid. You can actually set, let's say you want to always keep your battery high, and then run your generator. The moment the system loses grid, then it can activate the ATS for a specified runtime. So we'll look into that in detail on our commissioning session tomorrow as well.
Brian?
Yes.
Just a question quickly about the integration of the generator, okay?
Yes.
If you do a changeover and you connect the generator to the main input, okay?
Yes.
And the inverter is set up to feed back to the grid.
Yes.
What happens in that instance? Because obviously a generator doesn't want to have feedback power.
Okay, so if you install the generator or as a if you install the generator on the grid point, then your system should not feed to the grid. It should be limited on load output only. SunSynk, you can actually set a cell power, which is basically you can actually set the system to always take a certain amount of power from the generator, right? Which is usually called peak shaving. You can actually take, let's say you are using a generator, it's a 5 kilowatt generator. You need, obviously, if you're using a generator is a specified minimum load requirement that it should run to for optimum performance and all that. So you can actually set the system to always take a kilowatt from the generator. So if the loads they are a kilowatt and below, the inverter would not use PV or will not use PV or battery. It will take from the grid. The moment the loads go above that minimum rating that you have set, then the system, that's when it will start using the using the PV and the battery. So that actually helps you to not to feed back to the generator.
Okay, thanks. But we're going to handle that in tomorrow's commissioning so that we can just see the actual settings.
Yeah, I would also look into that in commissioning. What is called peak shaving. We can actually use it even on grid. Yeah, in scenarios where during peak hour the tariff price are quite higher than a standard hour. So on peak shaving, you can actually say during peak shaving, I only want to take a maximum of 100 kilowatt from the grid, and then I use my batteries and all that. We'll look into it more in detail tomorrow on our commissioning, because the system actually it has a function where you can actually set a fixed power that you can take from grid. In this case, we'll be using generator as grid as well. So you can actually set to say a minimum of 200 watts, right? That is if you don't have much spiking loads, then when we have a trickle power, it will simply separate from that 200 and avoid feeding back to the generator or to a prepaid meter if you've got those sensitive prepaid meters which usually trip. We'll look into that in detail as well tomorrow on our commissioning slide. So there is a generator relay on the system labeled GS on the newer version of the 5 kilowatt or 0.8 and 9, 7 and 8 on the older 5 kilowatt, and then GNS as well on the 8 kilowatt inverter. So this is the output of the ATS, which can actually use to automatically start your generators. If your generator uses a 240 volt ATS, the generator ATS uses a 240 volt, then there is a 240 volt ATS function as well on the inverter, which you would use to start your generator. But in most cases, this 240 volt ATS function, it's mainly used for neutral earth bonding. That is, if your property neutral and earth they are kept at different potential, then you can use this ATS to energize your relay so that you'll be able to bond your earth and neutral. And then if you are using a generator and you you would want to use your generator to charge your batteries, you would need to go on battery setup, and then you need to actually select you need to select the battery charge to notify the system that it can actually use the generator to charge your batteries, and then you can actually set the floating voltage, the absorption equalization. That is, if you are using AGM or lead acid batteries, and then you can actually set like the runtime to say you can actually set, let's say when the generator starts, it will need to run 4 hours, and then switch off certain number of hours, like such that it can be able to cool down and all. So you need to set also the charging current that you should use when using the generator to charge your batteries. Because if you are using the generator and your load is high and your batteries are charging at the same time, so that could impact your generator. Because if the total power that is using to charge the battery and supplying the loads exceed the generator, that could actually choke your generator. So when setting battery charge, please take note of your peak loads, usually in off-grid scenario, how much peak power you use, and then you calculate the equivalent in current, such that you won't overload your generator when it's charging your battery and supplying the loads at the same time. And then the when we are using the generator on connected to the Aux port, so basically the port will be acting as a generator input. You would need to go to settings, and then on aux load, and then you select what function are you using the port on. So you need to select gen input, and then you can actually set your peak shaving power, the one I was talking about earlier. So in this case, peak shaving power is set to 1000 watts. So it means the system could only take 1000 watts from your generator, right? And then the surplus of it will be supplied by PV and battery. So in an instance where you have a smaller generator, and then you'd want long time running off grid, and then your battery is low, and you'd know that your peak loads, if the generator is running alone, it won't be able to supply the peak loads. And then at the same time, if you run the inverter to supply all the loads, your runtime will be lower. Your battery is quite low. So you can actually run your generator, select peak shaving to 1000. So then it means the system will only take 1000 from the generator, and then the other half will be taken from the load. In that way, you will be able to run your generator to supply your loads and get the system to use less of the battery to supplement, thus giving you the runtime that you need on backup. And then when you're connecting the generator on grid input, as I've said, you can connect it through a changeover switch or a contactor. That is, a changeover switch is basically there to make sure that there is only one source of power, that is generator or grid, supplying to the system. So it's either grid or generator, not both. So you can connect the generator through a changeover switch, and then the setup will be still the same when you're using a generator as a grid input. You can have your non-essential loads, and then you can have your essential loads connected on the load port. Basically, when the generator is connected on grid input, the system would simply see the power as grid. So it will perform grid control. It wouldn't know that it's the generator running. So you should make sure that the loads are within the specs of the generator when it comes to a scenario where it has to to cover for the surge currents as well. So if you are using the generator, you also need the CT coil, such that you won't feed back to the grid. So this CT coil, you need to connect it on the output of the changeover switch or of the generator. And then this one will be used to make sure that the system will only produce for self-consumption. And then then from there you can do a setting which we're talking about to make sure you draw a certain power from the generator or from the generator, such that you won't feed back trickle power to the generator. So the generator rating should be able to cater for surge power. So when specing your system, usually don't use the average consumption of the appliances. Take note of the peak power. That's the most the problem that we encounter with the residential, especially with inductive loads, mainly being pumps. Someone would have a 1 kilowatt pump and then says, no, but this pump is a 1 kilowatt, the system is a 5 kilowatt, it should not trip. Not taking into consideration that when an inductive load starts up, it would draw in rush current up to 6 to 10 times. So whenever you're using a generator, you can use an average of ×5 the size of it when you're using an inductive load to spec your system. Because whenever you have a changeover from grid to UPS mode, then that's in most instances where the inverter trips, whether it's a SunSynk or what inverter. So in that instance, the voltage would have sharply dropped to 0 when you lost grid. On those milliseconds before the inverter voltage goes up, those inductive loads, they will draw in rushing current to compensate for the voltage. That's when and then it will overload the inverter. In most instances, you would find your inverter restarting continuously, because the moment it tries to start up, those inductive loads, they cause an overload, restarts, and then it will find itself stuck in the recycle mode. And then when you are using the auxiliary port, you can use it as a smart load port. In cases where you have an off-grid, in most instances, when you are running on off-grid, your loads, all your loads, they are catered for. It's in the afternoon. All your loads is 12 o'clock. All your loads have been catered for. The system, the battery is now at 100%. The system PV still, it has surplus. Rather than throwing away the surplus power, you can actually use the auxiliary port. Since the system it's an off-grid, it doesn't have the function for non-essential loads, right? So it can only supply loads connected on its backup, and we have still have excess power. You can use this port as a smart load port. Then you can connect your high power loads. For instance, you can connect your pump, and then the system, from there the system can actually power up those loads at a percentage which can be programmable. So you need on aux load, you need to select aux load output to notify the inverter that you are using that port as a load output port. And then you set the cutoff for the port and for the and then the cut on. For instance, as per image on screen, when the system battery gets to 100%, then you can activate the port, supply a solar power of 1,000 to this port, whether you are running a pump or you are running heaters and all that. And then once the battery drops to 95, then it switches off the what? It cuts out that port. So you can actually use this aux port as a smart load port as well. So this aux load port can also be used to connect micro inverters. Your client might request for a system, but already has micro inverters installed to the system. So this system can actually be used as a micro inverter input port, but the rating of your micro inverters should be at least 50%, at most 50% of the size of the inverter. So if you are using an 8.8 kilowatt, you can have a maximum of around 4 to 4.4, basically 4 kilowatt of micro inverters connected on this load port, and the port will be used as an input to the system as well. And then our next subsection will be paralleling inverter. SunSynk inverters, they can be paralleled, that is connected as multiple inverter. You can build any system size of preference, whether in a single phase or a three-phase scenario. So if you intend to parallel inverter, which is basically connecting more than one inverter, you would need to activate that on settings, advanced, and then multi-inverter. Then for the specific inverter, then you would need to activate it's connected in parallel, whether it's a master or slave, and then you would need to set the Modbus ID, which is the Modbus serial number SN. So for each inverter connected in parallel, it has to have a distinct ID. So it means all the Modbus ID has to be different for all the inverters connected in parallel. And then you would need to select which phase is the inverter connected to, right? So the checks when you're connecting inverters in parallel, the first check, all inverters, they have to be of same model. You cannot parallel a 5 kilowatt and an 8 kilowatt inverter. You should use the same model of inverters, and you should make sure that the inverters have the same operating system software, preferably the latest software version. If not so, then you can contact us with the inverter serial number, and before doing so, you should make sure that your inverter is connected on internet. That is, you are able to monitor it remotely, and then from there, then we can update the system remotely, or we can share the file for updating. Then you can just do it locally by connecting a cable to the inverter. And then obviously you need to set the inverter, whether it's a master, slave, and then the IDs. And then preferably the master inverter should be connected, should be installed in the middle. If you have, two, there is no middle between the two, so it will be side by side. But if you have 3 inverters in parallel, then make sure your master is the middle inverter, such that the communication to the slaves will be quite fast. And make sure that you have got a quality communication cable between the inverters. So as I've said, each inverter needs a unique Modbus number, and each inverter needs its own data logger. Each inverter would upload data on its own to the server. So each and every inverter has to have its own data logger. But the CT meter, you'd only need one CT meter, that is per phase on a single phase, that you need to connect to the master inverter. But the data logger, each inverter, it has to use its own data logger. But the CT, you only need one CT that will be connected to the master. And all batteries are supposed to be wired in parallel. That is the 48-volt batteries. They have to be, you should maintain your battery bank at 48 volts, and all inverters should be terminated. All inverters should be connected to the same battery bank. You can't have each inverter with its own battery bank. All inverters, they have to be connected on the same battery bank. So if you have 5 batteries installing to the system, all their outputs, you parallel them, basically you wire them to the same bus bar or line, and then all inverters in parallel, they have to simply tap on that line, such that when the batteries are empty, they'll be empty for all inverters. The moment you separate the battery banks, one inverter will still be having battery, while the other doesn't have, especially in a three-phase scenario, and that will give a communication alarm. So the master is when you're in a single phase scenario, the master is the only inverter that communicates to the what, to the battery BMS. So it means your CAN bus cable, you would hook it to your master inverter. So in a single phase scenario, you would select parallel. For the master inverter, select master, set the ID, and then the phase will be a phase, for instance. Your slave inverter, your other slave inverters, they will be slave. You select slave, select different Modbus ID, but on phase they'll be, you tick the same phase because they are simply producing as a single phase, which is basically on a single phase line. So basically this is the single phase configuration. You recommended is to, you can connect up to 3 SunSynk inverters in parallel on a single phase. So with a 5.5, you can, with the 5.5 you can go up to 16.5 kilowatt, while with an 8.8 you can go up to 26 kilowatt on a single phase. So with the single phase, you only have one master, and all other inverters will be slaves. And then on a three-phase configuration, you can connect up to a maximum of 9 inverters. You can connect up to a maximum of 9 inverters. Basically, you can connect 3 inverters in a phase, right? So you can give up until 9 inverters with 3 inverters in a single phase on each phase, right? So it means you can go up to 49.5 for a 5.5, and up to 79.2 for an 8.8 kilowatt system. And then on the settings, where now you are setting for a three-phase system. So for phase A, you would have master and slave, and then when you are going to phase B, then you select master, and then your second phase will be phase B, and then the slave, you would also select phase B. The same for the third phase, which is C. So your master and slave will also be selected on C phase. And then the rule of thumb, the rule of construction is the same for a single phase, same battery bank, different distinct Modbus IDs. If on the specific phases, the master should be the middle one if you have 3 inverters, and then basically all the rules, they are the same model, same operating software, and all that. After installing the inverter, you wouldn't want to get red lights and all that. You would want the systems to run smoothly. So on the system, if you go to settings, go to faults. If you have any faults or the inverter is beeping, yeah, that the audible sound, you can switch it off. Or on the fourth LED, that is from left, the far right LED, it's an fault LED. If it's red, so it means your system has a fault. So to access the fault, you can go to settings and then fault codes. Basically, the fault codes, there's a number to it with an F, for instance, F13, and then there will be a description for that specific type of fault. So basically, these are some of the faults that you might encounter with the SunSynk. So F13 is a working mode change. If you change the system working mode when it's running, when it's powered on, when it was supplying loads and all that, when it was active, and then you change it to parallel mode, then it will give an F13 alarm. So usually for this alarm, you need to just switch off the inverter, power it up again, but preferably all settings are done when the inverter is inactive, that is on but not supplying any loads. And then F18 overcurrent fault of the hardware. Basically, this is an overload alarm. Most cases mainly caused by rush currents or wrong spec of the system. And then DC overcurrent. This is if the inverter has a load demand which is quite high, and then it draws power from the batteries, the battery can supply power to its capability. And then if that current is more than the DC rating of the inverter, it will give this fault. So you need to make sure that's where you need to install a fuse, such that if there is an inrush current drawn from the battery, then you can trip that fuse and protect your inverter. Alternatively, if the battery is a the lithium would automatically switch off the battery when too much inrush current is drawn from it. And then the AC leakage and transient overcurrent. This is usually caused by earth leakages and all that. You can actually get this fault when you are running a generator on Aux Port. When you have multiple inverters, you can get this fault as well. And then DC insulation impedance failure. This is a common fault. This is mainly caused by low resistance between your PV strings to ground. So usually you just need to measure your PV strings and make sure none of your PV strings is shorting with ground. Like that is positive to earth, and then negative to earth. And then DC bus bar unbalanced. This is most common in scenarios where you have three phase, and then your inverters, they are not tapping from the same bus bar. Then there will be a DC bus bar unbalanced. The other battery will be saying my voltage is now 48 volts, while the other inverter is saying my voltage is 50 volts. Then there is a difference between the voltages. As I've said, when wiring inverters in parallel, make sure that all inverters, they tap to the same bus bar, so such that we avoid having a DC bus bar unbalanced alarm. And then the parallel communication cable fault. If your cable is not properly crumpled, then you would have this alarm, or you have connected on the wrong ports, or you have a poor quality cable, then you would have this fault. But mainly within the system, the fault will be mainly caused by incorrect settings on the inverter. An inverter in a single phase, and then on settings, then you set the master on phase A, and then the slave on phase B. So the slave would definitely give the fault to say, I'm a slave, but I don't have a master in my line. So usually to give this fault. So these are some of the most common faults that you'd experience. And then the other one, which I spoke about, the low DC voltage, which is basically you'll be having a low DC voltage at the DC input of the inverter, like the battery input of the inverter. And your inverter is set to operate as a hybrid or off-grid mode, then when the voltage is low, then the inverter would give that alarm. So these are one of the major alarms that you'd encounter when with SunSynk installations and all that. So basically that's all for our training today. Thank you for tuning in. On the bottom right, if you have any, you can go to our website, www.kathia.nh.co.za for more information on on our product range and everything. And then you can as well email us on support@kathia.co.za, or you can contact me directly on brian.msendame@kathia.co.za, or you can contact Tuva direct on tuamoyo@kathia.co.za. Soon we'll be launching our portal as well. Once it's ready, we'll share with you where you can go online, spec your system, get your quote and everything. Thank you for listening.